Now let's proceed to lesson 5, the motion equation. So these equations are useful when we are going to describe the motion of an object traveling with a constant acceleration along a straight line. So these equations can be derived by using the concepts of displacement, velocity, and acceleration. So in order to derive these equations, we are going to use the help of calculus. So first, let us try to derive this first equation here. So, sorry. So first we have that the final velocity is equal to the initial velocity plus the acceleration times time. So we remember that the acceleration is equal to the change in velocity with the change in time. So we can write this as a dt is equal to dv. And then integrating both sides, we will integrate this from 0 to a certain time t, and this is the initial velocity to the final velocity. So integrating, we have a t from 0 to time t, and this is equal to velocity v from the initial velocity to the final velocity. So we can write at minus a times 0 is equal to v final minus the velocity initial. So this is equal to 0, and we have v is equal to v sub o plus the acceleration times time. So now we have the first equation. To derive the equation here, let's first derive this one. We will use this equation. So for x minus the initial position is equal to the initial velocity times time plus 1/2 of the acceleration times time squared. So this part here is also equal to the displacement. So this is the displacement. So that's only for a little recap. So in order to derive this equation, we will use this one. So this is from v final is equal to velocity initial plus the product of acceleration and time. And we will also use the fact that the velocity is equal to the change in position with respect to time. So we first substitute this one. So dx over dt is equal to v sub o plus at. So interchanging, we have dx is equal to v sub o plus at times dt. So, we'll have to integrate both sides. So, from this is equal to the initial position to the final position. And this is from 0 to a certain time t. So, we have x from the initial position to the final. And this is equal to v sub o times time plus 1/2 t, 1/2 acceleration times t squared from 0 to time t. So, x minus x sub o is equal to v sub o times t plus 1/2 at squared minus the initial velocity times 0. Right, that is right. Plus 1/2 a times 0. So, this part here is equal to 0. So, now we have x, the final position minus the initial position is equal to the product of the initial velocity plus 1/2 acceleration times the time squared. Now we have two equations of kinematics. So, now let's try to derive this one. So, we have the final position minus the initial position, which is equal to final velocity plus the initial velocity over 2 times the time t. So, in order to derive this, we will use this equation. So, x minus x sub o is equal to v sub o times t plus 1/2 a t squared. And from what we have studied earlier, acceleration is equal to the final velocity minus the initial velocity over the time t. So, we will substitute this one to this equation here. So, we have x minus x sub o is equal to v sub o times t plus 1/2 times v minus v sub o times all over t times t squared. So, we have x minus x sub o times v sub o times the time. So, we can cancel this plus 1/2 the final velocity times time plus, so we can have the minus sign here. So, this is minus 1/2 times the final velocity times time. So, rearranging x minus x sub o is equal to 1/2 the 1/2 the final velocity plus the initial velocity times the time t. So, okay, we have the third equation for kinematics. Sorry. Okay. So for the last equation, this one we will use so v squared is equal to the initial velocity squared plus 2 times acceleration times the displacement. So to derive this, we will use that the acceleration is the change in velocity with respect to time, and velocity is equal to the change in position with respect to time. So we have two common here. So we will have dt is equal to dt, and we have dv over a is equal to dx over v. So rearranging, we have v dv is equal to a dx. So integrating both sides, so this is from the initial velocity to the final velocity, and this is the initial position to the final position. So we have 1/2 v squared. So from v sub o to v, and we have ax from x sub o to x. So we have 1/2 v squared minus 1/2 v sub o squared, which is equal to ax minus a times x sub o. So multiplying by 2, v squared minus v sub o squared is equal to 2a times x minus x sub o. And rearranging, we have v squared is equal to v sub o squared plus 2 times acceleration times x minus x sub o. So there you have it. We have derived the 4 equations of kinematics. So you can also try to derive this formula so that you won't have any trouble memorizing this. So kapag nakalimutan nyo, okay lang kasi alam nyo kung paano i-derive. Now that we have derived the motions of equation, let's proceed to the example problems. So first we have example problem 5.1. 5.1. So the speedboat in the figure has a constant acceleration of positive 2 meters per second squared. If the initial velocity of the boat is positive 6 meters per second, find the boat's displacement after 8 seconds. So first, let us write down the given. So constant acceleration A is equal to positive 2.0 meters per second. And we have V sub O, which is positive this is meter per second squared since that is acceleration and the initial velocity is equal to 6 meters per second. Find the boat's displacement after 8 seconds. So the time is equal to 8 seconds. For the solution, we are asked to find the displacement and we have the initial velocity, the time t, and the acceleration. So we can use this equation and this is just a direct substitution. So the displacement x minus x sub o, so diba displacement to, that is equal to the initial velocity times time plus 1/2 a t squared. Substituting the values, we have, dito na lang sa baba. So, we have initial 6 meters per second times time na 8 seconds plus 1/2 times 2 meters per second squared times 8 seconds squared. So, cancel natin yung second squared and then yung second. So, we have 6 times 8 plus 1/2 times 2 times 8 squared. So, we have 112 meters. Next, we have example problem 5.2. A jet is taking off from the deck of an aircraft carrier as the figure shows. So, this one. Starting from rest, the jet is catapulted with a constant acceleration of positive 31 meters per second squared along a straight line and reaches a velocity of 62 meters per second squared. So, find the displacement of the jet. So, example problem 5.2. So, again, the given constant acceleration is equal to positive 31 meters per second squared. So, reminder nga pala, itong mga equation na to, pwede lang natin siyang gamitin kapag ang acceleration natin ay constant. So, next, we have the final velocity. So, that is positive 62 meters per second. So, find the displacement of the jet required. So, for the solution, Okay. So, meron din nga pala ditong statement na from the deck of an aircraft carrier starting from rest. So, ibig sabihin, ang ating initial velocity is equal to 0 meters per second. So, find the displacement of the jet. We have the initial and final velocity and the acceleration. So, ang pinapahanap sa atin ay the displacement. So, we can use this formula. Since meron tayo nito, merong acceleration, and we can solve for the displacement. So, again, direct substitution lang siya. So, we have v squared is equal to the initial velocity squared plus 2 times acceleration times the displacement. So, 62 meters per second squared is equal to 0 meters. Sorry, this is in... So, sorry, mali. So, dapat 62 meters per second. Dito dapat yung square. 0 meter per second squared plus 2 times positive 31 meters per second squared times the displacement. So, 62 squared is equal to 3,844 meters squared per second squared. So, this is equal to 0. Is equal to 2 times, So, 2 times 31, let us write down 62. meters per second squared. So, times x minus x sub o. Then, we can now get the displacement. X minus x sub o is equal to 62 pa din. So, 62 meters.